This lecture is called Swim-Bike-Run and is going to introduce us to the concept of energy and the concept of physical work. It says the only place success comes before work is in the dictionary, and that's by the famous coach Vince Lombardi. So we want to take a look at what our expectations are for this particular lecture, and what they are is that students will be able to identify the factors that are necessary for physical work to occur. So you should know that physical work is very, very different from the concept of work that you now think of. If you say, hey, I'm going to go work on my physics homework, that doesn't mean the same thing as, hey, I'm going to go do some physical work. You need to be able to distinguish between work and power. Those terms, especially work, energy, and power, tend to be interchanged quite a lot in common vernacular, but they're actually very different. So you need to be able to distinguish between those. And finally, you need to be able to use the formulas. You have the formula power equals work over time, and you have work equals force times displacement. So that's what we want to be able to do. So let's go ahead and get started. The first thing is energy. Energy exists in many different forms. Okay, there's a lot of different forms of energy. One of the key things about energy is always conserved in a given system. So if you have a closed, isolated system, energy is always conserved. What that means is if you have 100 joules, which is the unit of energy, no matter what you do, you can split this 100 joules up lots of different ways, but it has to always add back up to what you originally started. That's called the law of conservation of energy, and you should be familiar with it a little bit, but we're going to go ahead and expand on it. It means that energy can be converted from one type of to another, so solar into electrical and those sorts of things. What you see here is you see this is a how the electricity company determines how much to charge you is in kilowatt hours, and that's a unit of energy as well that we'll talk about a little bit later. But you need to realize that whenever you have the electricity company, they're charging you for energy. They're not charging you for power, which is what a lot of people think. So some common types of energy, there are lots of different types of energy, but some of the most common ones is the first one is chemical potential energy, and that's the energy that's stored in chemical bonds. So whenever you burn something or a chemical reaction occurs, what you're doing is you're releasing this chemical potential energy. So this is the one you should be familiar with from chemistry. There's also the gravitational potential energy, which is the energy that's stored due to the position of an object relative to the Earth. So if I have a ball and the ball's on the ground, it doesn't have the ability to fall, so it has no stored energy. But if I take that same ball and I raise it above the surface of the Earth, now it has the ability to fall. So because of that, it's storing what we call gravitational potential energy. A couple other types of energy. We have nuclear. Nuclear you should also be somewhat familiar with from chemistry. It's the combination or splitting of a nuclei to release energy. So anytime something is dealing with the nucleus, it is a nuclear reaction. So that's a really common one as well. You also have radiant energy, and radiant energy we'll study a little bit later in the second semester, but it is studying the energy that's transmitted by electromagnetic waves, including light. Okay. You also have heat. Heat is the transfer of energy by objects of different temperatures. So if you have something that it's 100 degrees and something's at 0 degrees, what you'll do is you'll have an energy transfer from one to the other. And that's actually something that we'll study in the second semester as well, called thermodynamics. But for this particular unit, in addition to gravitational potential energy, we're also going to look at kinetic energy, which is the energy of movement. And it's just as simple as that. If something is moving, it has kinetic energy. And in fact, the term kinetic means to move. You also have work, which is considered the action energy. So work is kind of considered the go-between all the energies. In fact, the definition of energy is the ability to do work, which means it's the ability to do something. You also have elastic energy, which is the potential energy due to the stretch or compression. Most oftentimes you see that with a rubber band, but you also see it with things like springs, and even atoms will vibrate back and forth whenever they're bonded to each other. So those are some of the common types of energy, and then you should be able to say, how do you go from one to the other? So in this one it says, describe the transfer of energy from the sun to sugar in a plant. And what you should realize, I don't know if you know this from middle school, but at the center of the sun, what you have is you have a nuclear reaction. You have atoms that are fusing together. So you're taking hydrogens and you're combining them together, all these hydrogens together, get slammed together, and eventually they make one helium. Whenever you have a helium, that's a nuclear reaction. So we're going to say we start off with nuclear energy. Then what we're going to do is we're going to convert that nuclear energy to what we see from the sun, which is light or radiant energy. Then the radiant energy travels to the earth in the form of sunlight. It reaches the earth, and that light actually hits the leaves of the plant where they're turned into chemical potential energy. Sometimes they leave the potential out, just chemical energy. So what you see is we've converted from one type of energy to another to another. It says describe the transfer of energy as a box is picked up off the ground and set on a table. So what you should realize is that you have a box that is on the ground. And when you pick it up, you're doing the action energy. The action energy is the work. So what you do is you're doing work on the object. When you do work on the object and you lift it above the surface of the earth, you have now stored it as gravitational potential energy. And people say, but wait a second, it's on the table, it can't fall. Well, yes, it can. It still has the ability to fall to the surface of the earth. So because of that, if somebody nudged it, it would still fall to the ground. So it's worked gravitational potential energy. And finally, it says describe the energy transfer as a car initially moving down the highway slams on the brakes. So what you have is you're initially moving. So since you're moving, you have kinetic energy. Okay, KE is kinetic energy. Now, when you slam on the brakes, you're doing work. Okay, that's that action energy. You're trying to slow it down. So you're doing work on the car. And as a result, I don't know if any of you have ever experienced this, but if you were to actually touch the brakes after you stop, they get extremely hot because all that energy is transferred into heat.